Good evening, everyone. I can see that people are starting to file in now. As always, in these first couple of minutes, we will just let everybody get settled while we wait for everybody to join us for week 4 of Big Data, a short course presented by IT Masters and Charles Sturt. So by all means, just say hello in the chat. Remember to set your chat to everyone. As Matt has just set his to host and panelists, I can see. And let us know where you're from and if there's anything you hope to get out of this last session this week, because it's going to be an interesting one. And of course, the exams will be available after this week as well. And more on that. I'd also like to say welcome to Matt and Lily. Matt's here, of course, to mentor you through the session, and Lily is going to keep an eye on the chat and keep saying hello. As always, I can see there's people here from all over the world, but I'm just going to let you quietly prop in for the next 2 or 3 minutes, and then we'll start. Okay, it looks like we're starting to get a few people in. So again, I'd like to say good evening, good morning, good afternoon, wherever you are in the world, to week 4 of Big Data. Challenges in Big Data we're looking at this week. It's my pleasure to get us all started. Remember this week, for those of you who haven't attended in the past, that we don't use the raise hand function. If you've got a question for our mentor, Matt, to be answered, then you put it in the Q&A. Otherwise, the chat is all for chat amongst everybody, basically. And I'd like to welcome Lily, who will be looking after the chat and giving you some answers to things like, as you can see here, where you can see the recordings from last week and the week before, how you can log in, all of that sort of stuff. Before we start, I'd just like to make mention of a couple of things that are coming up as well. We have our next short course starting in a very short time. Normally we allow about a month in between, but there's only 2 weeks until the next one starts. We'll be launching that course tomorrow, and it's called Next Gen Security. It's based around the Palo Alto course called certification, I should say, called PCCET. And so watch out for that in your inbox, or have a look at our short courses website to have a look for the data tomorrow. The data won't be up on air until tomorrow. And the other thing of interest at the moment is that next Wednesday we'll be running a lunch and learn session. It's on AI, and it's titled, Can we tell when AI is lying? And our mentor, Luca Ewington-Pitsos, who's done an AI short course for us before, will be talking about some new research that one of the large learning model people have been doing, which gets to the bottom of whether they can actually understand what's going on within their models, and therefore can tell when AI is telling the truth or not. So without much further ado, I would remind you to address all your comments to everyone in the chat. Otherwise, only Lily and I and Matt can see it, which is great, but when we reply, the others won't see it as well. And the chat is a really good place to get to know everybody else in terms of, asking questions amongst yourselves as well. There's lots of really interesting information there. I can also see there's people from all around the world, from Africa, South Africa, Queensland, Zambia. Literally, we're always from A to Z in our courses. So with all that in mind, I would really like to welcome Matt Constable on board to take it away with Big Data for week 4. How are you, Matt?
I'm well, Shane, and thank you very much for the introduction. Welcome, everyone, to our last week in our Big Data online course. So over the course of the last 3 weeks, we've looked at the components, so what big data is. We've looked at the components that make it up in terms of the software and hardware components at a general high level. And we've looked at some of the different types of information and sources of information that come into these systems to make up these big data repositories that are stored in data warehouses and data lakes for us to do all sorts of fancy analysis on and pull all sorts of information from. Tonight in this last little session, we're going to be looking at the 4 to 6, arguably, challenges in big data, which all happen to start with the letter V most conveniently. So we already know from the last few weeks that big data refers to these really large and complex data sets that are quite difficult to process using normal, everyday, sort of traditional data processing applications. We needed to find a different way to be able to process this massive amount of data quickly and efficiently in order to generate outcomes or answers to questions that we had involving that particular data set. And as we've seen in previous weeks, a lot of companies use it to drive business decisions and to target specific marketing campaigns or to advertise certain products or other sorts of advertising. Of course, because of these very large data sets that we're using, because they come from a very wide range of different sources, there are significant challenges involved in managing these large data sets. And typically, we talk about them as being categorized by the 4 V's. So volume, velocity, variety, and veracity. And we'll look at each one of these in turn over the next 15, 20 or so slides. It's important that we have to build up an understanding and a knowledge and appreciation around what these challenges are in order for us to then develop strategies and develop toolkits and tool sets that allow us to efficiently and effectively use our big data resources that we have. So, as I said, back in week 1, we alluded to the 4 or maybe 6 different types of V's that we talk about. The first 4 are common. You'll see these mentioned in a lot of different places. And so they're volume, so the size of the data that's within your data set. And we're talking about individual specific company or industry type data sets here. We're not talking about all the possible data that's available on from all the possible sources. Even if we look at it in that using those subsets and those categories, there is still an awesome amount of data available to companies and industries. Velocity simply refers to the speed at which that data is generated and processed as well. So firstly generated, depending on the sources we get it from, that information can be generated at an amazingly fast rate. And in terms of how we're going to use it, we need to be able to process it intelligently and efficiently in order to be able to generate the answers to the questions we have or to generate whatever outcome we're trying to look for. Variety refers to the different types and sources of the data. So we've already seen, we can have structured and unstructured and semi-structured data. And we know that there's lots of different potential sources of information now. It's very common for data to be sourced from social media platforms, for example, so Facebook and X and Instagram and all these other applications that are commonly used. They're a massive generator of information for us, particularly as retail companies trying to sell products or advertise to certain target audiences. Veracity refers to the uncertainty in the quality of the data. So this is uncertainty or variation in the quality of data, and this can be directly impacted by the source that you might get it from. So think of that as relating to integrity of data in a way. The other 2 here, value and variability, are not always talked about, but I think they're still relevant. So value is how much the value is contextually to you, okay? And is it from, and whether it's from a reliable data source or not. So the more reliable the source, the higher the, or the less uncertainty in the quality of that data, then the more valuable it could potentially be to you, depending on what you're using it for. And then variability is how heterogeneous the data is based on its different types and forms. So let's look at each one of those in a little more detail in turn and see how we can perhaps some of the strategies, big picture strategies we can use to potentially manage these particular challenges. So volume. As I said before, this refers to the scale of data that organizations that use big data and pull this data in from different sources have to store it and process it. And the specific challenges are around the storage requirements, which can run into peta or exabytes of data. So that's a lot of information, trillions and trillions of bytes of data. We also have to guarantee its availability for the systems that are processing it, or for the people that are processing it and using it in order to generate outcomes or to target advertising at certain demographics, for example. So the data has to be accessible and retrievable when needed. If it's not, then it's of less value to us, or it might provide us value too late. And so the key point of that is we need to make sure that we can process the data in a timely and cost-effective manner in order to be able to get whatever outcome we want from it, or to answer the questions that we need the answers to. And so some of the solutions to that, which we've looked at in previous weeks, so we're not going to spend a lot of time on any of these, but just know that these are the solutions that are used for these challenges, is something like Hadoop, HDFS. There's a Hadoop distributed file system that we talked about in week 2. So it's a method for storing large amounts of information or data that we can bring in from all these different sources across distributed platforms, storage platforms. We could use some sort of cloud storage solution as offered by Amazon or Google or any other cloud provider that you are comfortable to use. We could also implement data compression and archiving. So compression is obviously taking out repetitive pieces of data from within the data and replacing it with something smaller, a smaller object of data. So for example, taking out all the combinations that are identical and replacing them with a single character as an example. So finding patterns in the data to compress it down, to remove and then compress. We could also archive. That's a little bit dependent on the type of data and what we're trying to use it for and whether it's timely. So in other words, if we have something, if we use data on a monthly basis through a particular summary process that happens once a month or however often the timeline is, then once that first lot of data is processed, we might want to archive it, push it off somewhere else into an offline storage system to maybe go back to at some other stage if we need to, but it's not necessarily relevant for the here and now. So again, that's to do with the time frame over which the data is actually relevant, given the context. Velocity, of course, now refers to the speed of a couple of different things. So the speed at which the data that we're using and capturing is generated, how quickly can we collect it and store it, and then how quickly can we process it based on the questions that we are posing to our big data systems. So the challenges around this revolve around this real-time data processing idea. So this is particularly relevant when we looked at our discussion last week on cybersecurity and things like incident handling and enhanced or extended detection and response systems. It was really important that we're able to process and view our data and generate our analytic components in real time for it to be useful. If we couldn't do that and it was only available every few hours or every few days, then it's not going to be useful in that particular context. In a sales perspective, if maybe sales and marketing, it might not have to be quite so real time. So you can take a little bit more time in processing it. But for anything that requires real time data processing, then this whole combination of generation, collection, and storage and processing can be a real issue. If we're dealing with streaming data, okay, and need immediate insight. So again, that's real-time data processing. Streaming data means it's coming in all the time, okay, coming in either serially or parallel all the time. It's constantly being uploaded to the system. It's not something that we can go and scrape, for example, to use a term where we go away and we collect a whole heap of data from semi stagnant sources or semi-static sources. Streaming data is coming in all the time. So think of things like maybe security camera systems, okay, where information is constantly coming in from cameras and it needs to be constantly reviewed using some form of AI or object recognition or separation of voice and data, voice and video streams, something like that. Handling the rapid rate of data change and ensuring timely updates. Okay, so if we're looking at information streaming into our system that might hold static for a while, might keep to a certain level or value for a certain amount of time, and then all of a sudden can fluctuate quite a lot over a short period of time. So think things like maybe stock market prices, those sorts of things, data from those sorts of systems. The rate of change can at times be different. Okay, so it's not going to change at the same, it's not going to be a continual change at the same rate. It's going to fluctuate in how often it changes. And of course, for those sorts of applications, we need to ensure that we have timely updates and maybe not real time, but near real time understanding of what the system, of the data that's coming into our system and what it means for our outcomes. So some solutions include, there's a number of different stream processing frameworks, like these couple here from Apache. And their basic idea is, as with any sort of framework, it's a set of guidelines and standards and software components that allow you to process and understand and get good information from data that comes in that streaming environment. So as I was talking about before, say security camera type systems. Apache Spark, again, we're sort of keeping on the Apache theme here, is also a tool that allows you to do in-memory data processing. So that is actually have a large or a reasonably large volume of data actually in the memory of the processing device, which memory is obviously much quicker than having to do swaps backwards and forwards, even off the fastest storage devices. And then giving us the ability to implement scalable data pipelines. So in other words, we build a data pipeline which allows us to collect, store, and process our data as it's coming in from the various sources, but we need that to be scalable. Okay, so we either need to build capacity laterally, laterally, or we need to do it. So we either need to scale it, sorry, not laterally, vertically or horizontally. They're the terms I'm thinking of. So we either make the pipeline larger, or we add an additional pipeline in if it might be, say, for a sub process or a sub outcome that we're looking to glean from our data as it's coming in. The third challenge is also really complex as well, in that the variety is what we're referring to here is the different forms of data that we have to process, which of course includes those three data types that we looked at in week one. So structured, semi-structured, and unstructured. Remembering that structured data allows us to use lots of different query type languages. We have lots of relationships between the data elements in structured data, and so it's really quick and easy to pull information from that data set. Semi-structured and unstructured, a little bit more complex. Now, we did talk about in week two again, or maybe at the start of week three, or maybe, no, it was in week two, I think, where we spoke about different ways that we could convert unstructured data into semi-structured or structured data. And then also looked at the different, say, non-SQL type databases that we could use to interrogate our unstructured data as well. So there's a number of ways to obviously get around that. But the point is that we're trying to put data together from lots of different sources and from using lots of different formats. So all the different multimedia types, text-based types, and everything in between from simple to most complex. So we're talking about text and images, videos, and all sorts of sensor-based systems as well. One of the challenges, of course, with that leads on from all of that is that there therefore is no standardized, easy to follow data format that we can that's compatible across all these different sources and formats, and therefore allows us to perform our analysis in a quick and easy way. Because there is no standardized data format, it represents problems regardless of the type of data that we're talking about. Whether we convert it from unstructured to structured or not is largely irrelevant in this particular case. So some of the solutions we can use, which we've talked about, include data integration tools, as a couple of mentioned there. We talked about the NoSQL databases for either handling the unstructured data, and we also talked about ways in which we can convert unstructured data to structured. So all of those are valid things that we could do. This, of course, is where things like machine learning and AI come into it that are so much more valuable than our more traditional methods of searching or interrogating our data, particularly when we're looking at these non-traditional data types. Veracity. So veracity refers to how accurate our data is. So think of accuracy and integrity, and whether we can actually trust it. So is it valid? Is it replicatable? So if we have the same set of circumstances, will we get the same output? Are the sources that we're getting it from reliable sources? Or are they, I mean, we know nowadays that there are so many opinions, there are so many experts, there are so many influencers, so to speak, out on social media that often come up with ideas or thoughts or theories, providing advice to people that is not backed on any evidence. It's just an opinion or something they think of and think, well, this is a good idea. It worked for me, so it must work for everyone else type thing. So we've got to be really careful, particularly as businesses or enterprise or government authorities, for example, using big data systems. We have to be really mindful of the trustworthiness of the data that we're putting into our systems to be able to answer the questions that we ask from the interrogation, examination of the data. Because if we're not, then our outcomes are not really valid. So think of garbage in, garbage out. If you put rubbish into a system, you'll get rubbish out of it. If you put quality in, you'll get quality out. So the challenge of this relate to this idea of dealing with this noisy, incomplete or inconsistent data, which we see a lot of, particularly on social media platforms. The old he said, she said thing, all these differing opinions. Anyone who's ever been a member of a specific group, whether it be to do with an athletic pursuit or academics, or whether it's your favorite football team or cricket team or whatever. If you're a part of a group, there are always going to be a large variety of opinions and all sorts of noise and chatter that comes out on the social media platforms that you might not, or you wouldn't see in normal, more civilized circles. It's easy to be a keyboard warrior and say anything alike. So in terms of the veracity of our data, we need to make sure that we are filtering out all that rubbish as much as we can so that the quality of our data that we're putting into our analytics or that we're deriving our outcomes or answers to our questions from is the highest quality that we can possibly get. So this one in particular is really, really important to research entities. Okay, so think tertiary institutions or medical researchers or anything that relies on good quality evidence to come up with positive outcomes for humanity. If we don't have good quality data, we're not going to get good quality outcomes, or we're not going to get a real outcome. We're going to get a representation of a version of the truth, which may be far and away from the actual real truth. So ensuring data quality and reliability helps us to make better decisions and helps us to deliver better outcomes from our big data system, whatever those outcomes be, whether that's targeted marketing, whether that's coming up with a particular treatment for a illness, or it's just enabling us to serve our customers better to make more money, education outcomes or whatever. This also helps us to remove data biases and inaccuracies that can result in the invalidation of our analyses. And so we use things like data cleansing and validation tools. So we actually check the validity of the information that we're putting in, that we're collecting, that we're storing, that we're processing. We clean it. We clean out the guff, the bump and the piffle, so to speak. We use data governance and quality frameworks. Okay, so it might be an ISO quality framework, or it could be just one that you've come up with within your own organization. It might be part of a regulation or legislative requirement, depending on the sort of business you're in or the industry that you're in. So it's about making sure that your data is best quality. And then we have to ensure that we regularly audit what we're bringing in and the quality of it. So not necessarily more importantly, actually, rather than what we're bringing in, but what we're storing from the information we're bringing in. Because clearly, as we're bringing data in, we're going to validate it and we're going to clean out the wheat from the chaff and then put the good stuff into our big data storage system so that we can then perform our analytics or our interrogation or our analysis on that particular information. And then constantly taking quality checks. So that might be about sampling small parts of the data to see that you get what you're expecting. Okay, the quality of the data meets your requirements. So they're the four big ones. Okay, so we've had our four big ones of volume, velocity, variety, and veracity. So they're the four that you will see mentioned pretty much everywhere when you talk about big data. And when you look at different types of big data implementations and you talk to vendors of big data systems like Splunk, for example, they will talk about those four forever and a day, and they'll answer all sorts of questions for you and give all sorts of different answers based on what their system is capable of doing. The last two, in my opinion, are equally as valuable or useful and need to be considered more. I guess this comes from the other side of the big data fence zone. So if we're selling or implementing big data systems, we worry about those first four. What can we provide the customer in terms of these four? In terms of the systems, hardware and software systems, and the way in which they can pull information from their incoming data sources, wherever they may be derived from. These last two are more from the user perspective. So value refers to the ability to transform the contents of our big data repositories into useful insights or useful information that allows us to improve our business practices or allow us to make good business decisions, which ultimately produce benefits either for us, our shareholders, or our customers, really is where we should be focused in an ideal world. But certainly allows us to generate more business profits, I guess. And so some of the challenges of that include identifying which parts of the incoming data are particularly relevant to the outcomes or questions that we want to pose. Clearly, big data has massive data sets. So there's lots of data that we're bringing into our systems all the time. And we've looked at the other four. So particularly volume and velocity we're talking about here, relevant here. We've got all this data coming into our system at breakneck speed. And we want to interrogate it just as fast in order to be able to get to our outcomes or provide the answers to the questions we want to answer. But to do so, we need to make sure that we are pulling out the relevant parts of our data. So when we looked at, and this sort of links back to, where was I? No, I've got to find the point I want to make. So here with Veracity. So it's linked back to this Veracity, right? So in value, we're trying to take relevant data. Now, when we talked about veracity, we were talking about noisy, incomplete, inconsistent data, quality of data. So when we get to value, we've already gone through this veracity portion. Right? So we've done a bit of data cleansing. We've validated the integrity or authenticity or the trustworthiness of the data that we now have in our system. But now we're looking at picking out only bits and pieces of the data that are relevant, specifically relevant to the outcome or the question we're trying to answer. Because it could be that we're trying to answer many different things. Okay, so I'll give you an example of a data set that I'm working with at the moment that I've spoken about, I think, in week 1. So I'm involved with a project using accelerometers, triaxial accelerometers, which measure movement more or less, or the speed and velocity of movement in 3 directions. So up, down, left, right, forwards and backwards. And we're using a number of different accelerometers, which are located on different points of different anatomical locations on our participants. And they perform certain movements over a certain period of time with a set amount of repetitions. And it generates massive amounts of data for us to sift through. So obviously the veracity of the data is important. So we need to, noisy data in this context would be accelerometry data that doesn't meet certain thresholds or exceeds certain thresholds. We have to also account for gravity, for example, in using this data. So we have to take that into account and remove the gravitational component in some of the analyses to get the right information we want or to get the right outcome. There are also several questions that we're trying to answer, specific questions that we're trying to answer from this particular accelerometry data capture. One of them is trying to come up with a specific location where an accelerometer can be worn on a human body to indicate this particular activity that we're doing with our participants. Then another question is, can we estimate intramuscular forces based on accelerometry data? Okay, so that's a different question. And so for each of those questions, there is a specific part of the overall data set that is relevant to each of those questions. So we need to be able to sort through that in an intelligent way. So that's where we're turning the raw accelerometry data into useful information, which then allows us to get to our outcome or to answer our question. So where on the body should we place an accelerometer to be able to detect this particular movement pattern or activity? Can we estimate intramuscular forces based on accelerometry data only? Obviously, we need comparison data from some other measure that does allow you to do that and compare them. So all of that is part of this particular challenge of value. So some solutions, again, some of these we're actually using. So advanced analytics and machine learning algorithms. Machine learning is something that we're looking at now to be able to detect particular events within our accelerometry data. As I said, you might capture a participant's movement for doing certain repetitions of this movement over a period of, say, half an hour. But triaxial accelerometers, so you've got movements in 3 planes, samples at 100 hertz per second, some of them 1,000 hertz per second. So there's a lot of data points that need to be gone through. So machine learning is a really good way to help us to speed up that process. So initially it's painful having to label data and go through a lot of that manually. Sometimes we have to go through video and audio sources to also match different data points up. But then once a machine learning algorithm has been trained sufficiently, it will make it a heck of a lot faster than doing it manually. So that's obviously the goal we want to get to in the end, but it all takes time. We could, in a business sense, also use data visualization tools to try and pull out some insights, some clear and effective insights from the data that we're looking at. And so what we're talking about really is focusing on specific objectives, outcomes, or questions, and identifying the relevant data to be able to answer those particular questions and outcomes that we're looking at. And clearly from a business perspective, that would be best linked to some sort of strategic or operational goal moving forward. And number 6, so we're almost done. It's only a quick one tonight, obviously. So hopefully there's a few questions. Number 6 is variability. So this is fluctuations in data over time. Okay, and if I go back to what I was talking about before with accelerometry information, spikes and drops in not so much the volume, but the velocity are very common. Okay, so there's and they are quite different. So depending on the location of the accelerometer in our case. So for example, as I said, we're using 9 accelerometers attached to certain specific anatomical locations on the human body. And during our movement patterns, some of them are quite active and others are not doing a whole lot. Now we have to bring all of that information together and summate it for certain reasons for certain parts of our analysis, particularly when we're trying to look at intramuscular forces. And so these spikes and drops across these different accelerometers can introduce sometimes unusual effects that we need to take into account, in particular when we're then feeding that accelerometry information into our data modeling schemes. The inconsistency in data formats and structures is not something that affects the project I'm talking about, but it certainly can from a business perspective. Pulling in the data I'm using is coming in from accelerometers. So it's all the same format, it's all the same structure. But there are plenty of projects, and you think about businesses that are marketing products or pulling information, pulling data from social platforms to determine whether their products are performing well or whether their business is performing well according to their customers. Lots of different formats, different structures, different types of media, primarily unstructured type data, then becomes a little bit more complex. And then we have to try to adapt to changes in the data sources and types. Okay, so if I hark back to the project I'm involved in, then we've got accelerometry data. It makes up the most of it, but we also have other data coming in from a motion analysis system. Part of that is accelerometry data, but some of it is gyroscopic information, which is slightly different again. We have some force plates involved to measure ground reaction forces. So again, that's different types of data. It's related, but it's different formats, different structures. We have to be able to manipulate it intelligently to piece the story together to generate our outcomes and to build answers to our questions. And so things like the implementation of adaptive data models can help us to adjust for and regulate those changes in data patterns that might exist depending on the data source that we're getting data from. We can try to use real-time data analytics to capture the data as it evolves. And in fact, the motion analysis system we're doing allows us to do that. So we can see in real time what the accelerometry and the gyroscopic information is showing us, and we can adjust our system. We can tweak it to either build a slightly different view of the model or to take inputs from other data sources that allows us to change and evolve as our participants are going through their movement patterns. And then cloud-based solutions obviously are becoming far more popular now. Many of them around now. We sort of briefly talked about cloud services. Most people will be familiar with them. They're everywhere. So that helps us to scale the resources that we have at our disposal dynamically. So we can scale vertically or horizontally, as I was talking about before. So we can make our system bigger, for example, or we can add extra systems into it as well to then implement that more distributed platform that we've been talking about all the way through. And that really is the 6 main challenges that we're talking about. As I said, the first 4 challenges are mainly from the sort of pure perspective of big data. The last 2 challenges will be, so your value and your variability will be more related to your individual need. So the individual outcomes, the individual questions that you are asking from your big data system, if you like. And so they will be quite varied right across all industries. Even if you're within the same industry as someone else, your value and variability still may be quite different to someone else's. Whereas the first 4 are common concerns that everyone has to look at. These last 2 are a little bit more specific to individuals.
Well,
So with that, what questions have we got, Shane?
we've got a small number. I think you're explaining things extraordinarily well tonight, which probably makes it easier in terms of the questions.
Hang on a minute. Are you intimating that I haven't done that previously?
Not at all. Not at
Uh,
all. It is unusual that we're close to finishing at this time, though. Normally it's about 20 minutes later. The challenge to convert big data into information that can be presented in new formats. For example, traditional bar graphs don't cut it anymore. With new software tools that are interactive, real-time, and graphical, like helicopter views for management, they need much more processing power. Is this challenge value or variability?
mm,
Or is it outside it?
no, I think there's definitely a degree of value in it. Absolutely, particularly when you're talking about, in particular when you're looking at, because the bar graphs, the graphical helicopter view for management, that's about delivering value in some way to those that need to make decisions about it, to make decisions about the questions or the outcomes that you're trying to drive. The variability is an interesting one. I think there's also a little bit of that. So I would say that that is going to cut across both. But as I said, value and variability are very specific or can be very specific based on your individual data sets and your outcomes and the questions that you're trying to answer. So I think there's a bit of both in that. I think that's a good question, but I think there's a bit of both in that.
Yeah, I think a big part of that is trying to devise what the relationships you are going to sort out are in the first place. That's often the hardest part.
Indeed.
What was used to speed up the process before machine learning was introduced? Are there alternatives to machine learning?
Excuse me for a minute. I've just got an alarm going off in the background. So speed up processing before machine learning was introduced. Well, the interesting thing about machine learning is it's one of those processes, and I found this out through my own practical experience in recent times, is that machine learning is ultimately very good for speeding up things, speeding up the process. But initially, it's painfully slow because you still have to train. Like most cybersecurity systems, and we talked about this a bit last week, in that you have to be able to train it properly. So give it a good baseline before it's really going to be useful. And for some machine learning systems, you have to pass an awful lot of data through them before they get to that particular stage. So they're not quite as it's not quite as speedy as what you might think initially. But having said that, uh, yeah, previously to machine learning, the idea was to use certain algorithms. So there was almost a heuristic algorithms and basically throwing more power at it, more hardware at it. So more processing power, more distributed systems. So scaling either horizontally or vertically, just throwing more power at it. Really, machine learning provides speed through artificial intelligence, if you like. So it's a different type of speed. We still use obviously hardware speed, so throw more resources at it. But the machine learning allows us to better define certain patterns and allows us to identify things more specifically than what simple processing power obviously would.
Okay. Um, how do some organizations justify the cost of big data solutions in cybersecurity? What metrics are used to evaluate the ROI?
Well, it depends on the value of the data assets that they're trying to protect. Ultimately, it comes down to that. So if the data assets they're trying to protect are not particularly, so they're more generic in nature, for example, then they might not be able to justify the use of those types of cybersecurity systems to protect their systems. But if you're talking about health organizations or financial organizations, government organizations, people who deal with intellectual type property or high value research, then the value is there already. Particularly when it's information about people like health or financial information, there's obviously value in that for any criminal that can come in and steal it, for example, or if it gets compromised in some way, so integrity, so either confidentiality, integrity, or availability, the value is already there. So the data is very valuable. So the requirement to protect it is just as valuable. So you don't mind spending the sort of money on it.
A bit
So
like
really,
insurance, though,
oh,
really.
sorry.
It's a bit like insurance, isn't it?
Yeah, it ultimately comes down to how valuable are your assets to you as an individual or organization. And sometimes it's not very valuable at all. Other times it's extremely valuable. But having said that, the information, think of it this way, that the information that you're trying to protect doesn't always have to be of value to anyone else other than you. It's the value you hold in that data will determine how much you're willing to spend on it. So whether you spend this amount of money on these big data cybersecurity systems in order to protect that information. And if your data is worth that much money to you or worth that much sentimentally to you, or in terms of time or productivity or what efficiency to your business, then you'll definitely pay the money for it. So it comes down to that value that your data represents to you as an individual or organization.
There's also the cost of, repairing a breach in your cybersecurity. That the IBM stuff that everybody was sharing last week. I had a quick look at that. And one of the aspects of those reports was for any reasonable size organization, the average cost of a cybersecurity breach is in the millions. So that's a lot of big
Oh,
data to manage.
that's right. And we looked at that in terms of time the other week, didn't we? When we said that, often you'll see that average for that particular report was, I think, 213 days or something. That hackers had been could be in a system, and then it would take another 70 odd days to actually get rid of them. All that costs money, and more importantly, arguably, time. So if you're protecting against all of that and preventing that from happening, then the benefits are obvious.
How about we go to something slightly different? It's a question relating to the quality of data. In your experience, how do organizations balance the trade-off between speed and accuracy in data processing?
Well, that's not really yeah, it's not really related to the quality of the data is the quality of that coming in. So the accuracy of the data processing. So in other words, the accuracy of getting to an outcome or answering a question may not necessarily be related to the quality of the data. That might actually be a function of the data processing process itself. The speed, and in terms of the speed, everyone wants to do it as fast as they possibly can. If there's, I can't think of too many reasons why the speed of processing would result in a bad outcome unless there was something broken in a system. And I say that because I'm separating the quality of the data as it comes in from the quality of the processes that handle that data to then generate the outcomes and the answers to the questions. So it comes down to, I think it's more important to ensure that you have quality data coming into your systems, and then as long as your processes have been validated, then I don't think it really matters how speedy they are, and the accuracy of the outcomes you're going to get is more related to the quality of the what you put into the system. So as I said before, garbage in, garbage out, good data in, good data out. And that's well, and from a research perspective, that's the assumption I'm making there is that you are asking the right questions. So if you're trying to use a data set to answer completely different questions, then you're going to have a problem.
Yes, you have to know what you're looking for to some extent. Although big data does throw up relationships that you might not have thought of very often if
No,
you're asked the right thing.
absolutely, absolutely. Sometimes you can, and that's because of that speed of being able to process through this, which we can't do with traditional methods and we can't do manually. Sometimes you will, and I've encountered that with the project I've been talking about. Sometimes you get to a point where you go, oh, I hadn't even thought of that particular outcome, and yet there's some data here that's indicating that is a possibility. So yeah, that's absolutely true, Shane.
How do we create relationships in data which is not structured and not symmetrical?
If it's not, so if it's unstructured, in other words. So we talked about that a little bit the other week, where you have to turn it into structured data. So you have to interrogate it, analyze it to pull out the different points of commonality and build the relationships between them yourself.
Okay, so many questions here. As big data involves very large amounts of data, it's in the title, must the analysis software tools mostly be co-located with the data source with minimized latency, i.e., if you store your big data in the cloud with a hyperscaler, e.g. AWS, Microsoft, Google, would you need to use their own analysis tools or install tools in your VPN in the same physical data center autonomous zone in order for
I'll
it to
see.
work properly?
I love design questions because that's specific. That's essentially a design question in terms of your big data network. And the answer to any design question is, of course, it depends. So it would depend on what your expectations are in terms of generating answers or generating your outcomes. But you might have to use their tools. So use their own analysis tools if they are fit for what you want to do. Ultimately, you've got to look at the outcomes that you want to generate. That's the most important thing. There's no point having a big data system if you can't generate the answers or the outcomes that you want or need to grow your business or improve or find out whatever it is you're trying to find out. So, in answer to your question, if there is a problem with latency, then you will either need to address it by throwing more bandwidth, for example, at the latency, if the smooth round time trip delay, for example, is your issue, or throw more processing power by scaling either horizontally or vertically, you might need to do that. Or, as you said, you could possibly use the providers' analytical tools if they are fit for purpose. But if they're not going to give you analysis or the outcomes that you need, then using your own tools would be more the way to go. And if there's a trade-off between speed and getting the right outcomes, then you would take the right outcomes.
Yes, I noticed there's a comment here from Peter about, government requests and fraud investigations. The real issue there is always about accuracy, speaking to the last question, and speed is sort of a minor requirement in the end because the accuracy is primacy.
Yeah, yeah, that's right. And if you have to, that's right. If you're going to sacrifice um, anything, you don't want to sacrifice the quality, either the quality of your data or the quality of your outcomes, just to get something done faster.
In your experience, what lessons have been learned about minimizing alert fatigue amongst security teams? How can big data analytics be fine-tuned to prioritize the most critical threats? Any useful tools, techniques, advice?
Well, so lessons have been learned about alert fatigue. There's been plenty of those over time. Uh, d d d- in my experience, I would say alert fatigue is more likely to occur in an enterprise environment where you've got a single common team that are managing your systems, and so see the same thing every day, day in, day out, and can sometimes get a bit, oh yeah, flippant about things and say, oh yeah, that's just that again happening when it might not be. In terms of, places like CrowdStrike or Talos, which is Cisco's guys, you don't get that sort of fatigue so much because you've got massive teams regularly rolling over. You've got a lot of different customers. You've got a lot of different things coming in. And as you're saying, they've got really high quality baseline understanding of the customers that they're monitoring and of the types of threat attacks, so threat vectors and threat actors that might be acting on those particular customers. And so all that allows them to be very granular and very specific about the types of alerts that they pay attention to and the ones that are so the ones that they prioritize above other events. So it's all about having a really good understanding of your initial data set in this particular instance, because you're talking about baselining of specific customers. So if you've got a good understanding of that, then it becomes far easier to, even without big data analytics, it becomes far easier to determine what is potentially a real threat and what is just something that you can ignore. Having said that, there is always going to be the case where you'll have false positives and false negatives. So, false positive being one where you say, "Oh, this alert's bad," when in fact it's not, or even worse, the other false negative where you think something's okay and it turns out not to be. Obviously, you would rather have false positives and false negatives. If you get a false positive, people will complain that they've lost access to something for some short period of time because you blocked it. But it's better than letting someone bad into your system that's going to wreak untold levels of havoc at some stage, potentially later in the future, or just stay there for 200 odd days and then take you another 70 odd days to get rid of them. So it comes down to that base understanding of the data set that you are interrogating.
This is another in your experience. Are there any additional avenues you think organizations could pursue to ensure they stay competitive in a world increasingly driven by data? Of course, other than AI or machine learning.
Uh, To be honest, not really that I can think off the top of my head at this stage. Machine learning, the AI, the analytics that we've talked about, they're all you're all much of a muchness. So I don't think there's anyone in particular that I can think of off the top of my head that is using anything earth-shatteringly different to get a competitive advantage over anyone else in any particular industry. So you look at the companies that we were sort of talking about over the last few weeks in terms of the different types of the different components of big data that they're using and what they're using it for, and you'll see they're very similar. There's variations on themes, but they're all very, very similar. And you wouldn't say any one particular company has anything greatly advantageous over anyone else. And if there was something And look, I'm not a world expert on these things, but I would think that if there was something that existed that would provide that sort of advantage, you would see someone who would be streets ahead in there. They would guard it very closely, and B, they would be streets ahead of anyone else in their industry. And I don't see that in this particular area.
Okay. How would you justify the difference of drawing results out of data has been impacted due to unusual circumstances? For example, 2 years of pandemic, war, other political conditions, say on the shipping industry. The trends will obviously have great, changes to them based on those unusual circumstances. What do you do with the data then? How do you work on it? That sounds more like a BA question.
Well, yeah. Obviously, like specific circumstances like that, your data could be quite different, and therefore you can't really use it in comparison to data that hasn't been collected under those sort of circumstances. It's not a apples to apples comparison. So the simple answer to that is there's really no way to approach that where you can compare it unless you want to draw unusual conclusions or you want to take a stab in the dark on what that looks. It'd be like, if I take it back to the example I'm talking about with accelerometry data. Uh, if we, it's very difficult to say, for example, if we're looking at and I'm trying to think of an example I can give without talking too much about this particular project, but um, if we're looking at someone that was doing the movement that we're recording at a very low intensity, and it was normally at a very high intensity, then the data sets are going to be very, very different, and there would be no real logical way to connect them or to be able to compare them directly. So you would have to take those two extremes and compare apples to apples. If you're comparing apples to lemons or pears or something else, then you're probably grasping at straws more than anything. You shouldn't be doing that. You need to compare apples with apples. So if your data sets are collected at very different times or they're affected by, as you're talking about, big impacts like pandemics or wars or things like that, then really they're a different data set, aren't they? They're a totally different data set under a different set of circumstances.
Absolutely. A couple of basically the same questions been asked twice in different ways. What sort of cleansing and validation tools are out there? Are they something that are easily available? Are they human programmed or are they AI driven these days?
The answer is both. There are there are many different tools, open source, commercial, bespoke. I mean, really, when you think of data cleansing is a very specific process that's going to be targeted on your particular data set in a certain way. So not everyone will cleanse the data sets in the same way. So if you get two organizations, for example, that are bringing in data from exactly the same streams at the same time, they will have different requirements. So they will cleanse that data in a different way. So some of it might involve machine learning. That's a very good way to do it as well, based on your own labels and your own requirements. Or you may use it using some bespoke or open source or customized analytic tool to actually pull out the different components that you want. But again, you have to provide that input to the system on what it is that you're actually looking for, and therefore what is valid to you, and therefore what is invalid or useless, and therefore strip that off. So it might be that you are. So I mean, a lot of outcomes by necessity or by logic, I guess, are going to require data that is not fictional, that is not provocative, that is not fake news, so to speak. So you want it to be have the highest level of integrity and trustworthiness. Whereas in other data sets, you might be looking for all that because you're trying to report on, you might be trying to answer a question on what sort of wild scenarios are people coming up with. So it's going to be different. The tools that you use and the way that you train them will be different depending on your own context. So, and there's no single set tool or single application that I would say I use this for data cleansing. There's lots of different ways that you might do it depending on the outcomes that you're trying to get from the data that you're inputting to your system.
Okay, here's a question that I think I'll mainly answer because it relates to what I do every day. Some data is a very valuable asset to marketing companies, I expect, which can be made available to the owners to those who are willing to pay for it and can be accessed by opening up APIs, providing the data accessed is generic, i.e. not individual. Is there a trend towards opening up APIs? Well, there's whole piles of regulation around that over the last few years. Is it GRDS, whatever it's called, in Europe, which means you have to have specific consent
Yeah.
for people to use your data. There are other sets of generic data, GDPR, thank you so much. You have to have specific consent for your data to be reused or sold to third parties. And in most cases, you can't sell it to third parties. You can only use it internally. There are some data, such as things like what we call floating car data, which Google uses for its maps. When you get live traffic and things on maps, they actually pay for that data from a whole pile of transport and other organizations with tracking. And they have that as randomized, anonymized data, and they're allowed to buy that historically as well. And that actually helps everybody, so it's allowed to be done. But for marketing, yes, you need specific, very well detailed permissions these days. It's the bane of our life because we have to monitor that on everybody who unsubscribes from one of our emails, and we make sure that we don't send them again wherever we possibly can. Do you see organizations being caught out when they collect large data sets for a specific project and then suddenly they realize they have to retain it for longer durations than they might have expected or indefinitely due to legal requirements? But this may not have been understood when they collected the data initially, especially if legal retention requirements change.
No, I haven't seen it personally, no. Not here in Australia. I mean, in terms of when you go, look, my main level of experience in this is obviously an academic research environment, and all that is taken very seriously and planned out very seriously through a long, drawn-out ethical type process, and follows many guidelines and very strict guidelines in order to ensure that we don't have issues with those sorts of things. If legal retention requirements change in that they're, through legislation or something like that, then, of course, there's a possibility that you may get caught out. But notwithstanding that, if you go into it properly and dot all your I's and cross your T's, that shouldn't be an issue. And as I said, I haven't personally experienced that here in Australia.
I think, in fact, more often than not, we have the opposite situation where organizations have retained data for longer periods
Longer.
than anybody expected them to. And we find out when there's a breach. And then we say, why have you kept, phone ownership records for 7+ years after the time somebody's cancelled their subscription?
Or the other thing that that occasionally happens when people trip up is if they're doing some sort of research, so they're gathering data for a specific research project, and they haven't specifically got permission to then use that in subsequent studies as well. That can be a little bit of an issue occasionally.
It's become like chain of evidence almost.
Yeah.
Does ignoring bad quality, i.e. not processing bad quality data, considered as affecting the integrity of the data? So, if the bad quality data is missing from the data set, does that affect the overall integrity or does it add to it?
No, it improves the integrity in most cases. I will never say 100% of the time, but having said that, I can't think of a time where pulling bad quality data out would be a bad thing to do.
Depends what your
Um,
definition of bad quality data is,
well,
because
that's right. It depends on, it depends on exactly what you're trying to answer and the data that you bring in. But in terms of research, if I just sort of think about that for a second, if you know that a particular part of your data is not quite up to scratch for whatever reason, whether, the system didn't work on that day or it was too hot or it went outside, other sort of environmental restrictions for that particular data set, then you would still keep it, because it might be able to give you insights about something else later on down the track, but you might not process it in terms of what your main outcomes or questions were. So I can't think of too many times, and I can't think off the top of my head of a particular time where removing bad quality data is a bad thing.
Yes, yeah. Here's my favorite question of the night. Is there a place for small data?
I just saw that. Is there a place for small data? Of course there is. Absolutely. Small data predominates. There's more small data than there is big data, that's for sure. I mean, we're doing a short course on big data, so that's what we're talking about. But I think you would find worldwide there's more instances of small data models than there is large data models.
Absolutely. Peter's also chimed in to say that in Australia, for example, changes are coming that will prevent you from reusing old data. It'd have to be archived or deleted after a couple of the big data breaches that have been.
Oh, that's in in that sort of context there. In research, that's been sort of the case for quite some time. You have to be very careful about. Oh, no, you are able to use it, but you have to dot I's and cross T's very carefully.
Do you have any tips for increasing engagement with data or business intelligence reporting in management and operational business groups?
Oh, that's outside my scope of expertise, that one.
Okay. Uh, how do you check or interrogate data that's been extrapolated from a big data system?
Yeah, so that's a good question. You have to have some knowledge of what you're looking for and what's valid. So if you were just grabbing a big data set and asking it a random question, that might be very difficult to do. But you need to have some either baseline understanding or previous data sets or some sort of well-known guidelines or other definitions that allows you to compare against the data that or the outcomes that you're getting from that data to determine whether they're reasonable or not. The other thing, of course, you can do, and we often do in research too, is does the outcome that we're generating fit with known models, known theories, or our general understanding of the world? And if it doesn't, then we would question it for sure.
Okay. I've got this question a couple of times, and I think it's a bit specific, so you may not be able to answer it. How can countries improve their single window systems for trade, import, and exports with the generation of big data?
Yeah, again, that's one that's way out of my area of expertise. Try import and exports generation. Yeah, I mean when you think about it, big data is all about trying to provide you with some form of information from incoming data that allows you to make better business decisions, which is relevant to imports and exports. Um, how that would be related to a particular country, I'm not in a position to be able to answer that, but you could certainly use big data to generate outcomes and to answer questions that might be relevant for that particular question.
Okay. What are the major vulnerabilities in big data? I think we might have covered this.
Yeah, I did see that question earlier, and I was just pondering on what exactly that was. So, obviously we've got the six V's or the four main V's, and then the two extra ones that we talked about tonight. But in terms of vulnerabilities, if you're thinking about cybersecurity vulnerabilities like we talked about last week, then really they are no different to the cybersecurity vulnerabilities of small data systems or no data systems or any other system you can think of. Threat actors, threat vectors, protection mitigation techniques that you put in place, risk analysis, vulnerability and penetration testing, all of those sorts of tools, concepts, and theories are identical really, whether you're talking about a person sitting at home with a laptop connected to the internet, or you're talking about, a big data system that your corporation is using via internet connection that exists in a cloud environment somewhere. The potential vulnerabilities and the risk associated around that are all exactly the same. What is different, however, is the where the responsibility often lies, or how great the responsibility is for a particular set of risks or vulnerabilities. So if we think about it from a cloud environment, if we're talking about a cloud big data environment, then the vast majority of the responsibility or protection of those systems resides with the cloud service provider. And we as individuals using those particular systems would be responsible maybe for the data that goes into it, depending on where that data is coming from. If it's coming from publicly accessible sources, no, less of a problem. If it's PII or PHI or some other intellectual property, then we would have the responsibility for that. But the overall risks and problems are no different, no matter the size of the security system, the system you're looking at. If it's connected to the internet, it's fair game.
Okay. And I've said to everybody that, one or two last questions is about all we've got time for tonight. How might the emphasis on big data lead to the undervaluing of smaller data sets or anecdotal evidence in research, do you think?
No, I don't think it will. I don't think it will. From a research perspective, you look at everything. You look at all scenario, whether it's small or big data, that doesn't matter. I mean, big data systems are just, if you think in a research context, we use, big data systems when we're doing research in really large cohorts. Okay, so we've got a lot of information coming in from a very large sample space. And when we say very large sample space, like for most research projects, a sample space of a few thousand is going to be absolutely massive. I'm talking about using some components of big data in my research, and we've really only got in the tens of participants compared to thousands. But it also depends on what sort of data you're bringing in. So if you've got 3,000 participants, for example, and you ask them one question that's a yes or no answer, you haven't got a lot of data. Whereas for me, if I've got, say, 20 participants and we're doing 1,000 samples per second with 9 accelerometers over a half-hour period, and we're doing that, for every, then, there's a differences in that as well. But I don't think in research perspective, I don't think there's a likelihood in properly developed and properly carried out research. I'll put that caveat on it. I don't think there's a danger that small data will be swept under the carpet and dominated.
Okay. Pretty much the last question. In which situation, what's the worst case situation when you're processing big data, I think is what they're trying to ask. How would that come up?
So, in my opinion, and this is only my opinion based on my experiences, but I would say the worst case scenario is if you've got data where the integrity is being compromised and you don't know it or you are unable to detect it. That's a worst case scenario because it leads directly to outcomes that are not accurate, they're not valid, and you're getting the wrong answers to your question. So, I would take some of the other issues, so around speed and storage and different, mucking around with different types of unstructured and structured data and doing all those conversion processes and all the complexities we talked about, I would take any of those any day of the week over a failure of integrity. So if you can't trust your data, you can't trust the outcomes that you're generating.
Garbage
And
in,
and
garbage
certainly,
out.
sorry.
Always comes back to garbage in, garbage out.
Yeah, exactly right. And if you can't guarantee the integrity of your data, then the value, particularly in a research context, like I'm in, the value of your data is worthless.
Okay. Somebody's asking in the chat about, laws around the the use of history data was changing. We don't have the link for that. I think if you just look on Australian government websites, there'll be stuff in the news about that coming up soon. From an Australian point of view, every country is different. And I know that from
Yeah.
our viewpoint, when we're preparing emails to go globally, we also have the situation in which there is not only the European Union rules, there are Caribbean Union rules, the South American rules, and there are also African specific rules that we have to abide by in terms of data retention and who we can send emails to, etc., and pass contents
Yeah,
on.
exactly right. It's driven by that data sovereignty idea. So yeah, absolutely. Depending on where you're getting information from or sending information to, yes, you could have to, you might have to be cognizant of a range of different pieces of legislation for sure.
Hey, Matt, this question's been sitting here since the beginning. How do you rip data from action videos? I'm assuming that means to put it in a database.
So I mean,
It's the
there's
more
lots of
generic one.
yeah. I mean, there's lots of different ways you can do that. I mean, if you're talking about, you could do things like you can extract video and audio tracks, which I sort of spoke about a bit earlier at one of the points in there. You could, if you're talking about, obviously videos are movement based. What's the word I'm thinking of? I can't even think of it. Anyway, they move obviously because they're a movie. You can segment frames depending on what you're actually looking at. So an example would be, in the research I'm doing, we do video of movement patterns, and there are times when we have to actually extract data from individual frames. So individual points of movement or the joint locations or arm or leg movements at a specific frame we often have to pull out information from that. So you can extract it from frames. You can look at the metadata, so you could potentially pull out information about maybe the codecs that were used in the recording, the resolution, the frame rate, the type of camera, the date and time at which these sorts of the video or pictures were taken. If there's subtitle tracks, you could look at that sort of stuff. Um, Optical character recognition, for example. So if you're looking at extracting business names or addresses or slogans or signs or something out of a video, you might do that using OCR, for example. You might also use AI type engines to look for things like facial or object recognition, which is quite common in security systems as well. So all those sorts of things you can extract different components out of a single video to populate a data set based on those. There's probably others that I'm sure there's others I've missed, but there's some things I can think of.
That's a pretty good list. Well, I think that is it for this evening for this course. At the risk of being repetitive, I will remind everybody that tomorrow, if you look in your inbox, at some point there will be an email invitation to our next short course, which is called Next Generation Security. It's a preparatory course for one of the Palo Alto PCCET certificates. I don't think it covers all of the information, but it's certainly a good introduction. So that'll be live tomorrow on our short courses website. The other thing that is out there, as I've said a couple of times, is our lunch and learn session on AI. Can we tell when AI is lying? That is available by going to the website, the IT Masters website, and looking at the information sessions page. That's the only place you can find that at the moment. And we've got about 300 or 400 people coming along to that as well. Now that's lunchtime Australian time. So that's about 1 p.m. Australian. And yes, it will be recorded for people who are overseas and and in a bad time for it. And it will be placed upon our website for anybody that registers the day after the session. So probably next Thursday, Friday, it'll be up on the YouTube site. But if you register, then you'll get an email telling you when it's up and how to access it as well. So we encourage everybody to register. Even if you can't make it to the day to listen to it, you can actually get it later on. In closing, though, thanks, Matt. It's been a fantastic 4 weeks. Really appreciate it. As always, you've given us all the stuff that we need. And we look forward to the next short course. It's a big thanks to Lil for giving up her time 4 weeks in a row on a Thursday night and about to do it again pretty soon. For the next short course, And thank you to everybody as well, particularly in the chat. I noticed that there's a lot of really good information sharing that goes on there, and that is something that we really value and is fantastic. It makes our group of people that do these courses really special to us as well. So thank you, and good night, everybody.